Okay, so next I want to talk about specific types of phospholipids. These are similar to triglycerides, but there's two main categories, and they help build your body. Very, very important that we have them. First, we have glycerophospholipids. Now, these guys have, just like we had last time, we have the esters on two of where those OHs were. But the third one, we have a POO with that alcohol, and then this amino alcohol. I'll show you what those look like right down here. So these guys, have the ability to be the amino acids. Okay? Any of those three right there. So we'll talk about that impact in just a second. Let me get through sphingomyelins. So sphingomyelins are a lot different. A lot different in that they don't have an ester on this top one. So this is actually easy to spot how it's different. The OH goes over here. We have a double bond here and a big, huge, long chain. Highly nonpolar chain right there. Next, we have a nitrogen right there with this guy. And this is from a fatty acid. So that's how it's built, right? And then at the bottom, we have POOO. There's an O up here too, by the way. And it just goes to what's known as choline. And this choline has a positive charge right there. Sorry, that wasn't in your notes when I scanned them in. So this is used to make the myelin sheath that surrounds your nerves. Very, very important for you to have, right? So see how I drew out these amino acids. So see how this has an OH. These are the alcohols on the end. And see how we have this OH. Sorry, these are not amino acids, they're amino alcohols there. My apologies. Here we have another OH. But all three of these have charges on this side of the molecule. What that should tell you is, ding, 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 they're polar, right? And this where it says amino acid or amino alcohol, again, I'm sorry about saying that, that should say an O, because that's what it's going to combine with right here. Is it's going to have that O. So the H will not be there, but the rest of these will be. See how like here we have the H gone, but the rest of that's there? Here we have the H gone, and the rest of that would be there. Okay? So you don't have things that are polar hanging out with things that are non-polar. So what ends up happening is that little polar portion flips and says, I want away from you non-polar things over there. You're crazy, right? And so all of these oxygens and all of those charges flip to the other side of the molecule. They don't want to stay sticking out with those, right? And what this actually creates are two regions of this molecule. We have a whole section over here that's highly polar, not just a little bit polar like the lipids we were talking about. We're talking about highly polar on this side. We've got negative charges, we've got oxygens everywhere, and then we have this nonpolar region. Well, isn't it cool? This is what makes up your cell membranes. And that's what creates, you've probably heard of a lipid bilayer, right? So we have a lipid bilayer, we have the polar region, that's all this stuff right here, right? That's what sticks out into the wateriness of your body. And then we have the nonpolar region. See where these two tails come from? That's what these mean. And they're sticking together so that the nonpolar region sort of sticks together on this side and on this side. It's kind of like what we were talking about with the micelles and soap, but it's not the same because you've got two layers of that, not just one. That's sort of the difference. So this is actually what creates your cell membrane, and it allows things that you want to pass through, and it allows things that you don't want to pass through. They're not going near it. They just can't get through it. Because basically this polar region says, hey, you're not allowed through the nonpolar region. And that's the way it goes, okay? Super cool. So how does that work with soap? Just to show you really quick. So let's say we now have a bilipid layer, and you throw in a whole bunch of soap. Well, you would see those as kind of like that, right? Well, if we have a whole bunch of those things that insert themselves into a bilipid layer, what they can start to do is they can start to break this apart until the entire thing just busts open because it no longer holds together very well. Okay, so that's what ends up happening is they just, and eventually it will just break on open. That's why it's important to wash your hands and keep the soap on there so it can do its job and do it for 20 or 30 seconds, right? Okay. Other things that we need to know, cholesterol and steroids. So this is what cholesterol itself, actual cholesterol that you've been told about. This is needed in the bilipid layer to a certain extent. If not, your entire cells fall apart. So it gives some rigidity to those cells, cell membranes. We also need it in myelin sheath and nerves, but if you have too much, you all know this, it is not good for you. Okay. There's other categories of things that we need to think about. Bile salts. Bile salts are made in the liver and they're from cholesterol and they're stored in the gallbladder. This actually helps break down fats and that's important for digestion, right? So if you kind of like wash the stuff that you eat, that's sort of what these things would sort of be like. Now, some people live without a gallbladder. Some people live without these bile salts, but then they have a more difficult time breaking down fats as a general rule. Next, we have lipoproteins. So these are structures to transport lipids and cholesterol through the body. You've heard of LDL and HDL, low density lipoprotein and high density lipoprotein. Transport cholesterol. LDL is what deposits in the arteries, and those are not good. Okay. Next, we have steroid hormones. These things have steroid backbones and they're chemical messengers. So these are things like estrogens and testosterone, and that's why steroids affect your body so much, is that that's actually dealing with your hormones and how you feel and pushing you to do certain things on a fundamental level. And finally, we have adrenal corticosteroids. So these are hormones produced by the adrenal glands. You should know where those are, I'm hoping. This is things like cortisol, cortisone, and aldosterone. Okay, cool. Make sure you read this stuff. Talk to you soon. Thanks, bye.